Thanks for coming. My name is Yalong Yang from Harvard University. Today, I'm going to present you the tilt map, a novel interaction technique in immersive environments for transitioning between multiple visualizations. This project was collaborated with Tim Dwyer, Kim Marriott, Bernhard Journey, and Sarah Goodwin. Choropleth maps have been widely used. For example, the population density around the world, the unemployment rate in the United States, the birth rate in Europe, and many more. The basic idea of a choropleth map is using colors to encode numbers from low to high, and then assigning different colors to their geographic areas. Here we are looking at the population density of the UK. There are other ways to encode numerical values. Past studies have found some encodings are more effective than the others. We can see color is not a very effective encoding, while the most effective encoding is height. As choropleth map is created by using color to encode values, we can also encode the value with height, and we will get a prism map. Choropleth map is familiar to people, however, they use an ineffective encoding. Prism maps use an ineffective encoding. However, occlusion is inevitable in this representation, especially when seen from the side. It is also possible to use both color and height. In this paper, the first question we want to answer is, which one is a better choice? We found limited user studies investigating this issue. Furthermore, these studies were conducted on 2D screens. Their participants were only allowed to have one viewing direction. Their participants might suffer from occlusion and perspective distortion. We believe occlusion and perspective distortion can be alleviated in an immersive environment where the user can easily and intuitively change their viewing position and direction via body movement or object manipulation. The user can easily find the optimal viewing position and direction in an immersive environment. To systematically compare the effectiveness of choropleth and prism maps with and without color, we designed and conducted a control user study to evaluate them in an immersive environment. We identified tasks from known map tasks and previous studies. The first task we tested was an animatory task. Basically, we asked our participants to compare two values, but instead of only identify the larger one, we asked them to estimate the difference between the two. We expect this can give us a more nuanced understanding of the performance. We also tested another summary level task. We asked our participants to estimate the population density of a few contiguous areas. Again, we asked our participants to provide us a numerical result. To reduce learning effect, we used different data for each trial. To ensure the generated data reflect real-world patterns, we controlled the moron's eye of each data. Now, let us look at the results of every comparison task. The x-axis is showing the time and the y-axis is showing the absolute error. The lower means more accurate. Here, we are looking at average performance of choropleth map. Project it to the x-axis, you will have the time, and project it to the y-axis, you will have the accuracy. We use arrow bars to indicate the 95% confidence intervals for both time and accuracy. Let us look at the performance of the other two conditions. We can see choropleth maps were faster, but prism maps were more accurate. Let us check the other task. We get very similar results. We can also split the results by the size of datasets. Again, similar results appeared. We then look at the angle of the visualization. We found patterns that people would expect. Our participants placed the choropleth map vertically most of the time, while they frequently tilt the prism maps to see from the side. Our participants also ranked the visualizations in terms of visual design and readability. We use arrows to indicate that there is a statistically significant difference between two conditions. We can see Participants did not like the monochrome prism maps at all. They also preferred the colored prism maps over the Choropleth maps in terms of readability. We also asked our participants to rate their subjective confidence for each condition. Participants felt more confident with colored prism maps than the other two conditions. We believe this may be because the participant can confirm the answers with two different encodings. In summary, we found Choropleth maps were faster but less accurate. Prism maps were slower but more accurate, and participants clearly prefer colored prism maps. As each view has its own advantages and disadvantages, we started to think how we can have the benefits of each. One idea is to have complementary views. The idea of complementary views is to have different visual representations of the same data. Like in this example, the same network data was presented by a node link diagram and the adjacent matrix. So how can we create complementary views in the immersive environment? The easiest way can be placing different views side by side. However, the user may only see one view at a time and must switch views frequently. Inspired from the results of our first user study, especially the different tilt angles for different visualizations, we designed a novel interaction technique to combine a Choropleth map, a prism map, and a bar chart together. The user will first see a vertical Choropleth map. Once the user tilts the map to a certain angle, it continuously morphs to a prism map. It then becomes a complete prism map with more tilting. When the user tilts more, the prism map shrinks to bars on the map. And finally, all the bars will move to the same plane to form a bar chart. Let's see how it works in a continuous and interactive way. Additionally, the user can also stay at any intermediate stage. The transitions are also bidirectional, so the user can also change it from a bar chart to a prism map and then to a Choropleth map. We call this interactive technique tilt map. We also considered another way to have multiple views. Basically, the user can click buttons to change the view. To understand which method is more effective, we chose to only test the more complicated task and use the data of US and EU. In the US data, we use 5 states as the targets, and in the EU data, we use 10 areas as the targets. We again control the model's eye for spatial correlation. Let us straight to the results. We found tilt map had some advantage of accuracy over side by side, and was slightly faster than toggle. When we split the results into different datasets, we have some interesting findings. In the small dataset, the benefits of tilt map is more obvious, while in the larger dataset, such benefits were negligible. We suspect that is because participants were able to track 5 objects in the small dataset for tilt map. When we enlarge the dataset, 10 objects might exceed the upper bound of the human working memory. We also identified common strategies used by our participants. We used representative trials to demonstrate the strategies. The x-axis is the normalized time for a representative trial. Different color stands for which view the participants was looking at. The first strategy was only looking at Choropleth map and the bar chart. In the second strategy, we can see participants frequently switching between views. In the third strategy, participants spend significant time on the transition. It seems some participants relied on intermediate views, for example, the bars on the map, to complete the tasks. The last common strategy was basically spend roughly equal time with Choropleth map, prism map, and bar chart. We also identified strategies for other conditions. Please look at our paper for details. Lastly, Our participants liked the design of the tilt map. We also found participants felt less confident in toggle than in the other conditions. Many participants also commented tilt map to be intuitive and cool. They also liked the way it provides a new and easy way to switch between views. In summary, we conducted the first user study comparing Choropleth map, Prism map in their immersive environment. We designed a novel interactive technique that combines multiple complementary views in the immersive environment. We also systematically evaluated our novel technique, tilt map, comparing to side-by-side and toggle. Thank you very much for your attention. I'd like to take any questions.